Now let's consider the function f of z equal to sine z. It's possible to prove that sine z can be written in the following way. As a real part, which we usually call u, we have that this u is equal to sine x multiplied with the hyperbolic cosine of y. Moreover, we have that the imaginary part is cosine of x multiplied with the hyperbolic sine of y. Let's also recall the following two identities. These are elementary identities that you have learned before. We have that the square of sine x, if we add this square with the square of cosine of x, we obtain the identity. Moreover, if we subtract the square of the hyperbolic cosine of y and the hyperbolic square of the hyperbolic sine of y, we obtain also the identity. So these two identities is essential in what we are going to consider now. Because if we know let x be a constant, what's happening then? If x is a constant, then we know that this u, which I'm pointing to now, in this function u we have a constant sine x multiplied with the hyperbolic cosine of y. So we call this u, and we then know that dividing by sine x, we obtain that u over sine x is equal to the hyperbolic cosine of y. Similarly, we know that the imaginary part v is equal to this product, so if I now divide this expression with cosine of x, we obtain similarly that v over cosine of x is equal to the hyperbolic sine of y. If I now subtract cosine, the square of cosine, hyperbolic cosine of y, and the square of the hyperbolic sine of y, then we know from this identity that we are getting 1. So I replace cosine, hyperbolic, and hyperbolic sine with these two fractions, and then I obtain this identity. Recall that x is a constant, so in the we have here u squared multiplied with a constant. Similarly, in this term we have v squared multiplied with a constant. And in the uv plane, this corresponds to an hyperbola. Similarly, if we do the opposite, we let y be constant, then I'm doing similarly as above. We know that u is equal to this product, so if I know instead of dividing u with sine x, divide with the hyperbolic cosine of y, then I obtain that sine x is equal to this fraction. Similarly, recalling that v is equal to this product, I can divide by the hyperbolic sine of y. And what do I obtain then? I obtain that cosine of x is equal to this fraction. So now I'm going to use the elementary identity, this elementary identity. So I replace sine of the square of sine x with the square of this left hand side, and I replace the square of cosine of x with this left hand side, the square of this left hand side, and then I obtain this identity. And what is this? Recall that y is now a constant, so what I have here is u square multiplied with some constant. And here I have v square multiplied with some constant. And we know that in the uv plane this corresponds to an ellipse.